Okay, this is our last podcast on acids and bases, and we're going to talk about indicators because you really can't talk about titrations without talking about indicators. Okay, so indicators are simply a substance that changes color with pH, and they always have two distinct colors, one when it's ionized and when it's not ionized. They are usually weak organic acids, and they have an equation that goes like this. So here's the indicator. This H would indicate that it's a weak acid. Ion is just the anion. It becomes ionized, and so when it's an acid, it's one color. When it becomes ionized, after losing that proton, it becomes a different color. And that color shift tells you that that change has occurred. Okay, so here's the equilibrium equation. So think about this. If I were to add some acid to this equilibrium, which way will the shift go? So think about that and answer it. Okay, welcome back. I'm hoping that what you said is if I add acid, I'm adding more of this. It's going to cause my equilibrium to shift to the left. Okay, and when it shifts to the left, what color will it become? Answer that. Okay, so if it's shifting left, it should become color A. Okay, now what if we add a base to the same equilibrium? If we add a base, what's going to happen? Try to answer it. Alright, come back. So the way you're going to think about this, so you look at this and say, well, this is an acid, and this, looks kind of like a base, and this looks like an acid. So when we talk about the same side, well, what you have to think about is whenever we are increasing our acid concentration, we are decreasing our hydroxide, and vice versa. So if we're talking about adding a base, we're not talking about this side, we're talking about this side. Okay, and in this case, we are going to shift from left to right. Okay? When we add that base, what color will you see? Well, you're going to see color B. Okay. So let's talk about how to choose an appropriate indicator, because there's dozens that you could use. So first of all, let's get clear about two terms. One is the equivalence point and the other is the end point. Often get used interchangeably but don't mean the same thing. The equivalence point is where the moles of the acid equals moles of the base. It's the exact point where you have neutralization. Okay? End point is where the color change occurs. Okay, so it's when you have something visible. An end point is something visible where you see that color change. Your goal is to have your equivalence point and your end point be as close as possible, if not exactly the same. So what you're looking for is you want an indicator that's going to be changing color within this range. And if you go across, it's a pretty wide range, anything from 6.5 to 11.5. As long as you're in that area where you have that steep curve or that steep rise, that indicator will work. Alright, so let me just bring a picture here. Alright, so to make that happen, what you want is the indicator needs to change. So you need the pKa of your indicator to be close to your pH within this range. Okay? So you want pKa of the indicator to be as close a match as possible to a pH on the rise, or this area here. Okay? So why does that work? Well, if we think about it, pH equals, alright, before we even do that, if we're talking about this equation, where I have the indicator in equilibrium with the indicator ion, if you are at a point where you have both of these things present, you essentially have a buffer. Okay? So if you have a buffer, pH is equal to pKa plus the log of the base over the acid, or the log of the indicator ion over the HIN. Okay? So when you have these close to the same concentration, your pH will equal your pKa. Okay? So that's what you're looking for, is where your pH is equal to your pKa. Okay? So you've got lots to consider. So if you were taking, for instance, a weak acid with a strong base, crystal violet here would be a poor choice, because it is going to change from yellow to blue down here at a pH between 1 and 2, which is way before your equivalence point on a weak acid strong base, because that's going to be a endpoint that's greater than 7, right? Just like this would be a terrible choice if you were doing a weak base and a strong acid, because that's going to change down here in this range. Okay, so let's take a look at another one. So the Ka for a certain indicator is 5.6 times 10 to the minus 5. The indicator is yellow in its acid form and blue in its ionized form. So the question is, what color will the indicator be when the pH is 7? Okay, think about that. Alright, so let's think about this. We know the Ka of this indicator, so let's figure out what the pH or the pKa would be. So it's going to be the negative of the log of that Ka, and that would be equal to 4.25. So what you want is you want your pH to be about equal to your pKa, which is when your concentration of your base is about the same as the concentration of your acid. Okay? That's going to happen at 4.25 pH, which is pretty far away from 7. So it will not be a good choice, because your color is going to start changing down here at 4.25 before you get to the endpoint, or to the equivalence point. So it would not be a good choice. Okay, so we're going to stop there.